without knowing it, I feel like we've almost started to solve some of the problems that you've talked about. And, when Spaceclaim was developed, one of the goals was to develop a tool as another tool in the toolbox. You should be using the right tool for the job and not be locked into one single tool. And I think all of you do that at home. If you take yourselves out of the software world and go, to work on a car or a deck, you're using multiple tools for the job. Spaceclaim, direct modeling, feature-based modeling, surface modeling, they're all great for what they do. Direct modeling, where that fits into what you guys do, works well with trying to overcome the barrier of starting from scratch. With direct modeling technology, you can take in parts and geometry and designs from anywhere into a single workspace and start to push and pull and merge different designs together. You can go up to places like GrabCAD, take 6 or 7 different designs down, just use what you want and start moving forward. You never really have to start from scratch anymore, and that really helps the ideation phase and get you to move faster.
When are we going to go from 3D printing in the prototype environment? Arthur, you talked about even laser sintering way back, and now resin printing. But when are we going to see carbon fiber infused resins and liquid metals to where 3D printing is going to become part of our supply chain, not just in the prototype space?
It's not going to be possible to really know for sure, as you can imagine. I mean, right now, with say electronics production, you can't produce all the parts in a complex board on the same machine, the same environment. That's sort of an interesting challenge. So there's one of the things about looking at things like 3D printing, either at the high level or with the desktop 3D printing, is you get an idea, you intuit that it would be easy. You make the jumps, and you sort of hide from yourself some of the the costs involved. Not just cost of money, but materials and time. So there are a lot of things that feel like they're really close to giving you a chance to work with a whole bunch of different materials at once. These processes tend to be extraordinarily expensive, and you might have to try it more than once. So that application might be much easier with a constellation of other manufacturing tools. The thing that's exciting about 3D printing, and where it can continue to sort of step in and offer real change for everybody, is that you can think about the stuff you're creating in different way. The metaphors can change a little bit. Maybe you'll only use a 3D printer to do the joins and the specific points, like the joins and armature of some elaborate project, and all the facing will be another material. Well, you might have just sped up that project so it's affordable and extremely accomplished, and you didn't need every inch of it to be 3D printed.
I think what you're going to see is that you can 3D scan anything, but like you said, the hard part is in the reverse engineering and getting it precise and factoring in the quality and how you actually manufacture that item. I think we learned from the earlier panel, it's one thing to have the 3D file and another thing entirely to go out and actually produce it and to do it well. So I think